Multimeter 102 Beyond the Basics. Most of us know how to use the resistance setting, ohms, on a meter to find if a pair of contacts are in the open or closed state. But what if there are powered wires on the normally open contacts? One trick is to meter the normally closed contact and the common. If the normally closed contacts are currently closed, you could assume that the normally open contacts are currently open. But what if you need to meter the normally open contacts and there are live wires with voltage on them? You can no longer use the ohms setting. This happens because the voltage put out by the meter's battery will conflict with the voltage on the contacts when using the ohms setting. At the very least, you'll get a reading that's way off. You could also damage or destroy your meter, the relay, or the voltage source. You could also be injured or killed if the voltage is high enough. The correct procedure is to switch to the voltage setting and see if you can read the voltage across the contacts. If you see the voltage across the contacts, they are currently open. If you don't see voltage across the contacts, it means one of two things. Either the contacts are closed, the circuit is complete, and electricity is flowing, or the voltage source isn't there at all. Maybe a switch or breaker is open, or a power failure has occurred. If you read 0 volts, how do you know if the relay contacts are actually closed or if there is no voltage at all and the contacts are open? A trick that often works is to read each contact terminal to ground. For example, if you read voltage to ground at each terminal, then the circuit is live and current is flowing. But if you read 0 volts to ground at each terminal, the circuit is probably dead, but further investigation would be required to be sure. Basic concepts. Only use the meter's ohm setting on passive circuits or components, such as circuits that have no voltage on them, resistors, light bulbs, solenoids, etc. The reason is the meter is active and its battery pushes small amounts of electricity through the circuit when using the ohm setting. It's okay to use the meter's voltage setting on active circuits and components, as the meter is passive on that setting. When borrowing someone else's meter, pay particular attention to the kilo, milli, and mega symbols. Also, watch closely for the negative sign. They are very easy to miss. Use the backlight feature to help you see them. What can you do if the displayed reading is jumping around a lot? You can always borrow your grandfather's old analog meter, or you can turn off the auto range function. Go to a high range where the reading goes to 0 to get an idea of the upper limit. Then go to a low range where the reading goes to over limit to get an idea of the lower limit. Occasionally, you can use the hold button, if your meter has one, to get an idea of the range that the reading is jumping around in. If your meter has a max-min button, you can leave it on each setting for about 20 seconds to find the range of the readings. If your meter has a bar graph display, it will not only tell you the range that the meter is jumping around in, but also how often and how fast. Have you ever wondered why, when you meter a long run of cable, the reading starts low and can take up to a minute to drift up to a higher, steady resistance? The reason is that the two conductors are slightly separated by thin insulators and act like these capacitors. It takes the meter battery a while to charge up the static electric field between the two conductors. Notice how close the wires are in these cables. They are separated by an insulator, so they act a little like a capacitor. Some meters do not read exactly zero point 0.0 ohms when you short the leads. Check the meter you are using by shorting the leads and check for the meter's lowest reading. You sometimes need to know this if you are troubleshooting a dead short. As you get closer to the short, the cable's resistance lowers. 16-gauge solid copper wire has a resistance of about 4 ohms per 1,000 feet, so every 500 feet of two-conductor cable equals 4 ohms. If we measure the resistance to the short and we get 8 ohms, we know the short is about 1,000 feet from the panel. If we measure the cable from the end of the line and the result is 32 ohms, we know that the distance from the end of line is about 4,000 feet. The measurements we just talked about only work if your meter readings are very close to 0 ohms when shorted. If your meter reads more than that, you must do the math. Your body measures somewhere between 20,000 and 10 million ohms between your hands. Results depend on how sweaty you are, how much contact there is on the meter leads, and other factors. If you try to measure a 47,000 ohm resistor while holding it in both hands, your reading will be way off. Only use one hand when using a meter on components or wires. Most meters use these symbols to show the position of AC versus DC readings. Some meters have only one position for both. You need to use the function button to choose DC or AC. If you ever have to move the red lead to a different socket to measure amps, make sure the meter is rated for what the circuit will provide. When using the amps socket, the leads have a dead short across them inside the meter, and they will pass all the current in the circuit. When you get done measuring amperes, make sure you move the red lead back to the volt-ohm socket before you take the next voltage or resistance reading. I've known technicians who did major damage to equipment because they forgot to do this. Feel free to add disagreements or corrections. We hope you found this video helpful.